proportions. Okay? And it's going to work very, very similar to how all of our hypothesis testing in the past has. We're going to lean on that four-step process. Just some of our computations, the formulas that we're going to use are going to be tweaked just a tiny bit. So our template remains the same. This problem says, a study of adverse symptoms in users in over-the-counter pain relief assigned subjects at random to one of two common pain relievers. They're either taking acetaminophen or ibuprofen. In all, there were 650 subjects who took acetaminophen, so that's an important number to write down. So we have acetaminophen, or acetaminophen, which had a sample size of 650 individuals, and 44 of them experienced some sort of adverse symptom. And that's compared to ibuprofen, that had a sample size of 347 individuals, and of those, 49 had adverse symptoms. And adverse symptoms might be like stomach ache or, whatever. We want to assess the evidence that the two pain relievers differ in the proportion of people who experience adverse symptoms. So not that one is greater or less than another, but simply that they differ. So I'm just going to put that off to the side, that not equal to, that's what we're interested in. Do they differ? Okay? So we see right out of the gates that we're dealing with proportions, right? We're comparing two, so this is going to be a two-proportion z-test that we're doing. The problem actually breaks it down into the 4 steps and then asks us in a 5th step to construct a confidence interval. So we're just going to go through our 4-step process. Step 1 is part 1 in the problem, step 2 is part 2 in the problem, etc., etc., etc. So we got to set up our hypothesis here. Step 1, we got to assign what is my population, what is the parameter, what's my null hypothesis, my alternative hypothesis, and then at what significance level am I testing this. So the population is, let's go back, it says 100 and our subjects are just, okay, so it's just people who take pain relievers. And if I wanted to get a little bit more specific, I could say people who take over-the-counter pain relief, right? This isn't folks who are on Oxycontin or Hydros or whatever. This is just over-the-counter. I've got a headache or a kink in my neck. And then my parameter, we're looking at the true difference in proportion. So we want to see if there is a difference between these two proportions. Our null hypothesis when we're comparing two proportions, or two means for that matter, is that they are the same. There's no difference in adverse effects, context to this question, no difference between the two proportions. My alternative, because it doesn't wonder if ibuprofen is more symptomatic or less, it's simply asking, are they different? We're going to say proportion 1 is not equal to proportion 2. And if you wanted to, you could say A and I instead of 1 and 2, but I'm just going to indicate that acetaminophen is 1 and ibuprofen is 2, and so I'm going to leave my little sub 1s and sub 2s there, if everyone's cool with that. And then it doesn't give me a level, a significance level, so I'm just going to default to my 0.05. And that's going to be anything more rare than that is going to give me enough evidence to say, yeah, there definitely is a difference between the two. So when I'm looking at this one in particular, I put this in the lesson notes, but you have options here. This could be P1 is less than P2, P1 is greater than P2, but in this case, it's that P1 is not equal, right? My null hypothesis is always that they're going to be the same, and then my alternative, they're going to differ in some fashion. And the problem will prompt you in which direction they differ.
Mr. Marsh?
Yeah.
Could we do something crazy like P1 minus P2 is equal to 0 or
Totally.
not equal to
Yep.
0?
That is totally equivalent, right? So all it would take is a little bit of easy algebra to move this over here. I would just subtract P2 from both sides. My null hypothesis could be P1 minus P2 is equal to 0. My alternative, P1 minus P2 is not equal to 0. So yeah, those are equivalent.
Perfect.
Mm-hmm. Conditions. Before we get started, because I am going to have to talk about my simple random sample, my normality, and independence for both of these guys, for both P1 and P2, I have to show that they're both sets satisfy the conditions for a z-test. But I need to do a little bit of side math first. I need to figure out p hat sub c. Now p hat sub c is my combined sample proportion. The combined sample proportion is going to be the number of successes in both my groups, group 1 and 2, divided by the number of trials in both the groups, N1 plus N2. I'm going to use that combined sample proportion for not only my conditions, but I'll use that number in my calculations as well. So let's find the combined proportion of adverse symptoms here real quick by doing that math. So it's just 44 plus 49 divided by, whoops, be careful, order of operations is a bully here. So divided by 650 and 347. And that gives me a combined proportion of just over 9%, 0.093. So I'm going to use that value when I'm talking about normality for my conditions. So it says in my problem that 650 subjects took the acetaminophen and 347 took the ibuprofen, and it looks like the assignment of the subjects was at random. So it was stated in the problem that this is a random assignment. So we're good there. Now for normality, in order to prove normality, our formula is the sample size of the first times the combined proportion, and that has to be greater or equal to 10. Also, the sample size of the first times the complement of the combined proportion has to be greater than 10. And that has to work for both sides. So this side over here, it's the sample size of the second times the combined proportion greater or equal to 10, and the sample size of the second, and that combined proportion complement also greater or equal to 10. I'm not even going to drop those numbers in. Our sample sizes are huge. 10% of 650 is 65. 90% of 650 is ridiculously larger than 10. Likewise, 10% of 347, that works, and 90% of 347 is also bigger. So we are definitely normal for both sets. We have a very large sample size, so that's going to carry us across the way. For independence, I could say all acetaminophen, or aminophen, users is indeed greater than 10 times 650, so there's definitely more than 6,500 individuals out there who take acetaminophen. I think that one's Tylenol, right? Tylenol is acetaminophen. And then same for ibuprofen is also greater or equal to 10 times 347. So we're good there. So it looks like all our conditions are satisfied, and I'm going to write down this number off to the side because I know I'm going to have to use it again on my calculations part of the show. Okay? So whenever we're comparing something, be it means or be it proportions, we have to show that we're satisfying both groups in order to do our z-test computations. Calculations. So this one, there's a lot going on with this calculation, which makes me grateful for my TI calculator. It allows me to just drop it in and not have to worry about order of operations here. I'm going to put the formula up on the board, but know that once you've written it down, once you've subbed everything into the formula, please, please, please use your calculator in order to actually do the work. All right, so step 3, calculations. Z equals, now we're comparing the proportions, and so I'm going to take my first proportion, my first sample proportion, that's p hat sub 1, minus p hat sub 2, minus my second, because again I'm looking at the difference between these two, and I'm going to divide that by the standard deviation of the difference of the proportions. That's a lot to say, but it looks like this. It's that combined proportion times its complement times our sample sizes under 1. So 1 over n sub 1 plus 1 over n sub 2. Let's go ahead and drop our values in there. I'll real quick figure out what p sub 1 is. That's 44 divided by 650. Gives me a 0.067 minus my p sub 2, the ibuprofen side effects. That's 49 divided by 347. 0.14. So we can see that there is a difference. There's almost twice as many side effects for ibuprofen as there is for Tylenol, for acetaminophen. But is that enough to convince us? Let's go ahead and drop everything else in. Here's that 0.093 that we calculated earlier times its complement, which is 0.907, times 1 over our sample size, 650, plus 1 over our sample size, 347. Okay, then I'm not going to put any of that in my calculator. What I'm going to put in my calculator is me going to stat over to the test menu and down to the one proportion z-test. So stat over to the test menu, one proportion, or two proportion z, my bad, sorry, two proportion z, and it's going to ask me for my successes and my trials, and my successes and my trials for the two populations. So I'm going to drop in 44 and 650, and I'm going to drop in 49 and 347. And then I need to pick my alternative hypothesis, that's the not equal to, and calculate. All right, so here's what we get. It looks like that's a z of negative 3.8 with a p-value. It's got some scientific notation going on, so that's 0.00014. So there is a huge difference, right? We see it here, but we see how rare of a difference that is. If these two were in fact equal, having a difference of side effects that large happens, let's see, that's 1 in 10, 1 in 100, 1 in 1,000, 1 in 10,000 is our probability of that occurring randomly, so that's wicked rare. So let's conclude. Just like everything, we've got to have those 3 steps of our conclusion. We need to show the evidence. We have to claim some sort of choice. Are we going to reject or fail to reject? And then we have to put that choice into the context of the problem. So our evidence is right here. That's that p-value that is 0.00014, and that's way less than our established alpha of 5%. So that makes our choice very easy, right? We are going to reject the null hypothesis that proportion 1 is equal to proportion 2. They aren't the same. They aren't the same. But because we never put in our alternative that acetaminophen has less side effects than ibuprofen, we have to kind of stick with our not equal to. And so the context here is, it seems the proportion of side effects is different between the meds. So there's ample evidence here to show that they are different. But it's going to take a confidence interval to show us how different they are, right? In what way are they different? So that's the 5th question on that test, is to create a confidence interval and see how different the two actually are. So that's where we're headed right now. Okay, step 5, or the confidence interval. Just like our calculation step, I'm going to show you the computation and where to sub in the numbers, but we're going to let our calculator do all the heavy lifting when it comes to time to figure out what this interval actually is. So we are comparing my first proportion, p sub 1, that's my acetaminophen, and p sub 2, that's the sample for my ibuprofen. And then I'm going to apply some margin of error. That is my z star. And this is going to be based, again, on how much confidence we want to have. The prompt tells us that we should do a 90% confidence level. And then multiply that times the standard error, which is that same thing that was on the bottom of our last computation. So that's, again, that combined proportion times its complement and 1 over, or the inverse of the sample size of both sets. All right, so I'm just going to sub in numbers here real quick. Of course, I've immediately forgotten what my sample proportion was. Let me figure that out again. Okay, so that was 0.067 minus 0.14 plus or minus my z star. Z star can be found for a 90% confidence level at the bottom of my table C. Here I am at 90%, looking at z star. It looks like 1.645. 1.645. So that's saying that I'm 1.645 standard deviations up and down from the true difference. Times the standard error, which is 0.093 times 0.907 times 1 over 650 plus 1 over 347. And now that I've got that written down, I'm going to put none of it into my calculator. I'm actually just going to go to the old 2 proportion z interval, and all the values should still be in my calculator since I just did a test. Let's make sure that that's right. So test down to a 2 proportion z interval. It's b on the 84. It's way down there. And yep, they're already in there. All you have to do is adjust your confidence level to a 90%, 0.90, and calculate. And that gives us an interval of negative 0.1, I'm going to round 0.11, and 0.4. Now this negative on both of these values is really, really telling, okay? That's saying that acetaminophen has between 11 and 4% less side effects than ibuprofen. And those are the words that I'm going to write when it comes time to do my context, which we'll do right now. So I am 90% confident, confident that acetaminophen has between 11% and 4% less side effects than ibuprofen.